Hello, welcome to FX PhD. My name is Matt Leonard and this is class number 9 of our Katana 100 level course. So in this class we are looking exclusively at rendering and render passes, and we'll be then using that information next week to put it back together and cover a load of miscellaneous things that we haven't been able to get through so far in the course. So up until now we've been very much going back and forth between Pixar's RenderMan and Solid Angle's Arnold, but for this class I'm afraid we're going to be exclusively looking at Arnold. Now the reason why we're doing this is simply because to cover all the detail of both RenderMan and Arnold would basically just take twice as much time, and I don't want to spend that because there's already a lot to get through in this class. Remember however that the Katana 201 course is going to be very RenderMan heavy, so obviously I'm sure people are going to just move from 101 to 201, and you're going to get a huge amount of RenderMan in that second course. In fact, almost exclusively we're going to be in RenderMan for the more advanced Katana course, but for this class we're going to be in Arnold. Now, let's just go back and look at rendering in Katana before we move on. Let's remind ourselves things that we've talked about a lot already. So we know that Katana was developed really to address the problems of flexibility and scalability. And we also know that when it comes to rendering, that Katana is render agnostic, which basically means we can use any renderer we want. And the renderers that connect to Katana through a render-specific plugin basically out of the box are either Arnold or PRMan, but if you have some clever guys at your place, then you can use the API to basically develop and support other renderers such as 3Delight, V-Ray, or Mental Ray, if you so chose. Now, scalability not only is at the heart of Katana, but it's also at the heart of rendering itself in Katana. And both RenderMan and Arnold support procedures that can be basically evaluated on demand. And when we've talked about deferred rendering and things like that, that's what we're talking about with this rendering and evaluating on demand. Now, render time, basically they pass the screen description in the form of procedural recipes to the renderer, and so therefore you can hold much larger pieces of information in Katana and then only deal with them at the render stage. All that kind of stuff we've talked about, and it basically saves you having to write out massive scene data files such as the Pixar rib file or the Arnold AS file. Okay. Now, Katana provides 3 options when you right click on the render node, and we've right clicked on the render node many times in this course so far, and we've usually gone with the interactive renderer until last week we went with the hot renderer, and I didn't really explain what the difference was simply because I knew I was going to do it this week. So the interactive renderer, when you click on that, the scene generated at the node is sent to the renderer and the result is displayed directly on the monitor. That's what we've been doing all the time for this course, or pretty much all the time. Below that we have the interactive re-renderer, and that is pretty much the same. It basically renders the scene to the monitor, but from there anything we do with cameras, lights, materials, geometries, etc. are basically updated. So think of the interactive re-renderer as your IPR in Maya or something like that. So if you want to just see things constantly update, the interactive renderer, or interactive re-renderer rather, is the way to go. Then we have the hot renderer, and we used that last week to deal with our shadows. And basically what this does is it writes the file, it writes the rendered image to a file, and then it displays it on the monitor tab. So the hot renderer is the way you actually write the file to disk. Okay. Now we also have some important rendering nodes. Now these are things like the render output defines, render settings, global settings, and object settings, and we've used a lot of these already throughout the course just because we've had to. So the render output define, this sets the type of render, so the color, point cloud, shadows, etc., and the channel, so that would be things like AOVs, the color space, the path name, and the final render description. Okay, so the render output define tells the renderer, or tells Katana, actually what we want to get out. Then we have render settings, and this sets the things like the camera, the choice of renderer, and the resolution. Okay. Then you have a node or two nodes that depend on whether you're using Arnold or RenderMan. So you've got the PRMan global settings or the Arnold global settings, and this deals with all the kind of fiddly bits to do with setting up the renderer. So if we were talking specifically about Arnold, this would be where you set things like the anti-aliasing, where you set things like the filtering, settings, lights, cameras, geometry, scene generations, all those kind of things. It's basically where you go into the renderer and you tweak it to make your images and the anti-aliasing and things like that look the way you want it to go. It's where you would go to make the render perfect before you hit it and get it going fully. Then you have the PRMan or Arnold object settings, and these are settings that deal directly with the objects themselves, things like the geometry. So this would be where you would say, I want to subdivide or add iterations to my geometry at render time, where I want to do smoothing to adjust things like normals, where you want to adjust things like the shadow settings, or where you want to say the object is opaque or transparent. So object settings, global settings, render settings, and render output defines. These things we're going to be looking at in Katana a little bit later, but this is basically what they do. Then we have this thing called the re-renderer control tab, and again I'll show you this a little bit later. This can basically change re-rendering behavior in a number of ways. Okay, so for instance, we can do things like change which materials and lights trigger the re-render and when the re-rendering should take place. So this is like, imagine this as the kind of the IPR control housing. This is how you control what's being done. Okay, now the re-render control is split down into two sections. The first section contains options that are render agnostic, okay, and the second section controls render specific options. So when we come into Katana in a moment, we'll look at both of those sections. Right, on to Arnold. Arnold is obviously created by Solid Angle. It was first written by a friend of ours called Marcus back in 1997, and it was actually named after Arnold Schwarzenegger. I kid you not. This is apparently a true story that Marcus and a friend of his had gone to see End of Days when they were writing Arnold, and I think it was Marcus's friend who basically made an Arnold Schwarzenegger impression at the end of the movie, and a load of people in the theatre laughed and thought that was very funny, and they basically said, oh, we should call the renderer Arnold, and they said, oh, that's kind of good, and so it stuck. So Arnold is actually named after Arnold Schwarzenegger. Great. Arnold is, as we know, an unbiased, physically based Monte Carlo ray trace path traced engine. So it's very similar to the way V-Ray works, and it's very unsimilar to the way RenderMan works and Mental Ray works. Okay, so that's what Arnold is. It's different technology to some of the other renderers. Now, Arnold in film. It has basically been the main in-house renderer at Sony Picture Imageworks since, I believe, Monster House. So anything from Monster House all the way up to Oz the Great and Powerful, Smurfs 2, things like that, that's all going to be Arnold. But it is finding its way into the pipeline of other companies, and some quite big companies. So people like Digital Domain have used it on Jack the Giant Slayer. ILM have used it on Avengers and also Cloud Atlas. We've seen people using it on things like 47 Ronin in the instance of Framestore. It's been used on things like Thor, Red Tails, Hunger Games, X-Men. So a whole bunch of movies are now using Arnold as a renderer for either all or part of their show. And probably the other renderer that they are all going to be using will be RenderMan. And although we weren't going to talk about RenderMan, it would be worth noting that RenderMan has really been around since the Wrath of Khan. So that must be, early 80s, and has really been used on every major historic motion picture for visual effects since then. So Terminator 2, Young Sherlock Holmes, Jurassic Park, Titanic, Benjamin Button, anything that's really won the Academy Award over the last 20, 30 years has predominantly been a RenderMan film. So it's quite nice in some ways to see another renderer now kind of pushing in and making inroads into the industry. So that's Arnold and the films it's being used on. It's obviously being used on other things, just like RenderMan, just like Mental Ray, just like V-Ray, but obviously those things can't necessarily be talked about, or we don't even know what they are until they get talked about. Okay. Now, the key to understanding Arnold is samples, and this is very, very fundamental to you getting out a good render that isn't going to take an age to actually process. So samples can be found in render settings and lights. Render settings, we're looking at samples that are in AA or anti-aliasing, GI diffuse, GI glossy, or GI refraction. Okay, so there's no talk about reflection and there's no talk about specular. Both of those are found in glossy. Okay, so it's a different mindset. In Arnold, there is no specular information. It is all glossy, which is reflection and specular tied together. And if you've been like me, where you've been in 3D for like what seems like a lifetime, we are very used to having a specular slider that you increase to make things look shiny. In Arnold, it just doesn't exist. There is no specular slider, and that's just going to be something you're going to need to get used to. It's all glossy, and it affects both specular and reflection as we kind of understand it. Now, also samples are found in lights, and so when you make a point light, a spotlight, a directional, sky dome, any kind of light you want to make, you have samples there, and the samples in the lights predominantly deal with shadows and soft edge shadows. Okay, so if you have a hard edge shadow, you only really need one ray, one sample, and it looks pretty good. The minute you blur those edges and you make the radius of the light bigger and you get soft edge shadows, that's where you're going to need to start playing with the samples specifically on those lights themselves. Okay, now understanding samples in Arnold isn't as straightforward as you might imagine. Sample settings control the quality of the rendered image. Okay, so that's what you need to think about. The only thing to deal with Arnold is samples to get a better image. Okay, now increasing the sample rate reduces the amount of noise, and that's all we're trying to deal with Arnold is noise. But obviously the higher the samples, the more render time you're going to get. And the actual numbers of samples is a square amount of the number that you type in. So if you go to AAs and you type in a number of 3, that's actually 3 squared. So you're actually producing 9, okay? So that's really important to remember, because you can start cranking up your sliders to like 7, 10, 12, thinking that's quite low if you're coming from, say, a V-Ray background. But all of those numbers are being squared, and so you're very quickly making some pretty high sample values. And this would be the same for things like GI diffuse, glossy, and refraction. So a sample of 2 would actually give you 4 because it's squared. Now, one thing also to remember is that the AA sample is a multiplier for the GI samples for diffuse, glossy, and refraction. So if you had, say, a GI diffuse of 2, which we know is a square, so that produces 4, and that will then be multiplied by our AA samples of 3, which is squared, which is 9. So we're basically taking 9 times 4 equals 36. Okay, so when you slide your slider in GI diffuse to 2, you're actually producing 36 samples. Okay, because the GI, as we said, is then times by the AA. So that's really important to remember. It's quite hard to get your head around if you're not used to Arnold. So the AA samples, these basically have control over the number of rays per pixel that we traced from the camera. Okay, so it's coming from the camera and it produces, or it's the number of rays that are being produced. The higher number of samples, the better the anti-aliasing quality and the longer the render time. Okay, so this is specifically for AA samples. So in practice, you may consider using values of something like 3 to 5 for medium quality, 6 to 8 for high quality, and rarely 9 to 16. Okay, so if you're pushing your sliders beyond 10, you are really into super high quality, and you'll definitely be noticing really low and slow renders. Okay, now remember that if you have your AA set to 16, because it's being squared, you're actually firing 256 rays per pixel into the scene. So I'm going to keep reminding you that everything is being squared. Okay, so here's an example image from Solid Angle. This is just a straightforward image. You can see what the AAs look like at a sample of 1, 3, 5, and 10. Okay, so you can see as we're increasing them, we're getting better and better quality, though the difference between 5 and 10 isn't that significant. Obviously between 1 and 3 is a vast difference, but as you're going up, you're obviously firing more and more rays, and there's going to be a sweet spot where basically upping the slider any more isn't really going to produce an image any better quality that the human eye can see. So like with all renderers, you're going to need to find where that is and make sure you're just under that so you're not wasting processor time. Okay, so let's now move on to talk about the GI diffuse samples. Now the GI diffuse samples basically control the number of rays fired when computing the reflected indirect radiance integrated over the hemisphere that we're using. Okay. When GI diffuse samples are more than 0, camera rays intersecting with the diffuse surface fire indirect diffuse rays, and the rays are fired in basically random directions within this hemisphere spread. Okay. Now noise is introduced when there are insufficient rays to resolve the range of values in the environment. Okay, so if you're getting noise, it's because you don't have enough rays being fired, and so you would need to then up the diffuse samples. Now remember that the diffuse samples are being times by the AA samples, so you're going to need to kind of balance those two out. This is what it basically looks like, another image from Solid Angle. So this shows the indirect diffuse ray sampling and the indirect diffuse noise. So you can see as we fire the rays in from the camera, it's basically hitting our object and then bouncing all over the place to create those additional rays. Now, indirect diffuse noise is one of the most common causes of noise, and it will have a number of different sources, and it basically appears as noise in the scene, usually in the shadow area. So that's where you need to look for it. Okay, and to get rid of the noise, as we said, we increase the GI diffuse samples. So here's some examples that I ran yesterday. We have a diffuse sample of 0, so we're basically getting no diffuse rays coming in at all. So the image that you're seeing is basically a closed box, other than the front face is gone, which is where the camera is looking into the box, and we have a doorway that has got a spotlight shining into the scene. So that's what we're seeing, a spotlight outside of that white door shining in. So 0 rays, we get a 6-second render. If we have one diffuse ray, you can see that we're getting a huge amount of noise because we don't basically have enough rays being generated. That render time took 15 seconds. Increasing the diffuse samples to 2 gave us a much cleaner render, but that jumped up from 15 seconds to 2, or rather nearly 3 minutes just to render that. Adding 3 samples pushed it up to nearly 7 minutes, and 4 samples pushed it up to almost 12 minutes, or just above 12 minutes. So between samples of 2 and 3, there's not a huge amount of change taking place. So this is where you definitely do not want to take your diffuse samples and say, oh, let's make it a value of 20 and see what happens. You will be waiting for a very long time. And remember that that sample of 4 is squared and then times by the AA, which is also squared. So you're actually making a lot of rays with a diffuse value of 4. Now, in a moment, I'm going to show you a Excel spreadsheet. Very exciting, isn't it? You can't imagine the quality we've gone to for this class. An Excel spreadsheet that will show you how you can see exactly what kind of rays you're getting. In the version for Maya, it gives you a readout, but in Katana you can't actually see how many rays you're generating once you start pumping sliders up. So it'll be a little thing that you may find useful. Now let's talk about glossy samples. Okay, and glossy samples are what we're talking about when we're talking about specular or reflection information. Okay, so the glossy samples control the number of rays fired when computing the reflected indirect radiance integrated over the hemisphere weight by a specular BRDF. Okay, now increasing this number to reduce the direct specular noise. Now we increase this number to reduce the indirect specular noise. which would basically be soft or blurry reflections. Okay. Now GI glossy controls the indirect or secondary light bounces for both specular highlights and reflections. Okay. The direct or first specular highlight ray is controlled by the main AA samples. So if you had your GI glossy all the way down and had a spotlight in the scene, you are still going to see what looks like a specular highlight. That is really just the direct or first ray coming into the scene. If you want to then get secondary highlights or reflections, that's going to be caused by the extra rays coming in from the glossy control. Okay, so here is the Stanford Dragon, some more tests I ran yesterday. In this first image with the big arrow, you can see that my glossy samples are at 0. I have a render time of 10 seconds, but that speck highlight that you see, that's the first ray that we just talked about. Okay. If we then increase the glossy samples to 1, you can see we're actually now getting reflection in the scene. And my render time goes up to 46 seconds. Adding glossy samples of 2, my noisy reflection begins to smooth out and my render time goes to 55 seconds. And then as we go up in glossy samples to 3 and 4, you can see we're getting 1.5 minutes and then 2 minutes 20 seconds. Okay, and again, by the time we get to 4 samples, we're getting a very, very smooth reflection there on the Dragon. Okay, so glossy samples, again, don't have to be up super high because they are squared and then times by the square of the AA. So again, lots of samples being generated. Then we have GI refraction samples, and the refraction samples work with transparency. Okay, so if you want to make something translucent, you're looking at the refraction area of your shader and your renderer. Kind of strange again, but you'll get used to it once you get into it. Okay, and the GI refraction samples control the number of samples used to simulate the microfacet based glossy refraction evaluations. Okay, now note, in order for a shader to become transparent, you need to turn off, because it's on by default, you need to turn off opacity using the Arnold object setting node, and we talked about that node earlier. This is one of the uses of this node. We basically need to go to the ray flag and turn off opacity. And by default, in order to speed up Arnold's rendering, it has this flag switched on for all of the geometry, basically saying it's all solid. So it doesn't have to try and calculate transparency. So if you know something's going to be transparent, you've got to switch off opacity. Also, the KT, or the transparency amount in the slider, determines the amount of transparency, where 0 is fully opaque and 1 is fully transparent. Okay, so keep an eye on that one. Now here are some examples that I've done. So the refraction sample of 0 and a render time of 10 seconds basically means that A, you can't see through the object, and B, well, there is no B. You cannot see through the object with your refraction set to 0. If you set them to 1, you can now immediately see through the object, but the refraction, which I've made a kind of a frosted glass look, is pretty noisy, and we're getting a render time of about 15 seconds. By the time we've upped our refraction samples to 4, our render time has only gone up to 42 seconds, so it's obviously still quite long, but we're getting a much smoother, nicer frosted glass look. Okay, so we've got rid of a lot of that noise by then. Now, so that is samples for both glossy, refraction, and AAs and diffuse. We now need to talk about understanding what ray depth is in Arnold, and this is quite similar to ray depths in other rendering packages, and it basically allows you to configure settings that limit the ray recursion based on the ray type. Okay, so higher values will increase the render time. So as an example, GI diffuse depth defines the maximum ray diffuse depth bounces. 0 diffuse depth is equivalent to disabling the indirect diffuse illumination. So when you have something to 0, that's often just disabling the whole thing. Now increasing the depth will allow more bounces of light for our diffuse rays into the scene, which will basically be quite noticeable, especially on interiors, which we'll have a look at in a moment. Okay, now currently the Arnold code only takes one random sample after the split has happened in the ray tree. Okay, so causing the region behind GI glossy reflection and indirect diffuse to have much fewer shadow samples than those that are viewed directly by the camera. Okay, so just keep that in mind. So here's a little example as to how the diffuse ray depth works. You've obviously got the ray coming from the camera into the scene, and then that fires and gathers diffuse from the surrounding information. Okay, so as the light hits the red and the blue and bounces, you're then going to get the purple back to the camera. Okay. Now this is an example. I only did a couple of renders for this one. This first scene is with a ray depth set to 0, though I've got my actual diffuse set to 4 and my AA set to 4, and you can see we're getting quite a nice image. It's not overly noisy, and it's taking about 1.5 minutes to render. The second image, however, I haven't changed anything in this one other than I've said that the GI diffuse ray depth is not 0 but it's 4, and so we're getting much more bounce information of those rays in the scene, and we're getting a lighter scene. Okay, so the scene is getting brighter because the rays are bouncing and the depth of those are going further into the scene, but we've obviously paid for that in that we now have a render of 5.5 minutes. Next up, we have the GI glossy ray depth. Okay, and the glossy depth determines the maximum number of times a ray can be glossily reflected. Okay, scenes with many glossy reflective surfaces will require higher value in order to look correct. Okay, and the minimum value of 1 is necessary to get any glossy reflections. So here's a pretty typical scene. I've got two chrome balls next to each other. With a glossy ray depth of 0, you can see that although we have the reflection coming from the sky dome, the actual spheres themselves and the ground are not being reflected whatsoever. And that took a render time of 55 seconds. And again, my AAs are at 4 and my diffusers at 4 and my glossy samples are at 4. Ray depth at 0 in the first image. Once I put my ray depth to 3, we now have those 3 bounces going back and forth between the spheres. If you look closely at the one on the left, you can still see there is a dark area where the ray depth runs out, and we are now getting a render time of 2 minutes 9 seconds. So it has increased the render time, but we're obviously getting what we want. From there, let's now talk about reflection, and reflection has ray depth as well. And this defines the maximum number of times a ray can be specularly reflected. So a scene with many reflective surfaces may require, again, a higher number to look correct. So here's my scene. I have 2 mirrors back to back with a nice blue donut in the scene. With a GI reflection ray depth set to 1, we are getting just 1 reflection of the donut in the mirror, and the mirror behind us is completely black. Once we increase our GI reflection ray depth to 10, we are now getting those 10 bounces. You can see we've got that kind of typical bounce mirror effect that you sometimes see. And you can see that although I've gone from 1 to 10, my render time has really only gone up by 8 seconds. So often increasing these values aren't making a huge amount of additional render time. Sometimes they are, sometimes they're not. Next, we need to talk about the refractive ray depth. And refractive ray depth is basically the number or the maximum number of times a ray can be refracted. Okay, so scenes with many refractive surfaces, again, are going to need more values. So if you have a look at the object here, this would be a hollow sphere. We basically have 4 surfaces that the ray depth needs to pass through, or the ray needs to pass through. So we have an outer surface, an inner surface, which would be 1 and 2. We then cross the inside of the hollow sphere to the other side, and then we have an inside and an outside face there. So to get a single ray through this hollow sphere, we're basically going to need a ray depth of 4. Okay, so here's my example, again rendered yesterday. With a ray depth of 2, we basically just have 2 rays passing through our donut, and then it goes black, and we just get a bit of reflection on the outside. Render time 1 minute 50 seconds. With a GI depth set for the refraction at 20, we now enable our ray to pass through 20 surfaces, and my render time has gone up to 3 minutes 15. Okay, so again, that does need to be cranked up if you are getting black in your transparent objects. It basically means your rays are running out and you're just getting a return of black information. Now finally, before we get into Katana, we have GI transparency ray depths, and this basically defines the number of rays allowed transparency hits. So a value of 0, the object will be treated as being completely opaque. So in the first image, which again is courtesy of solid angle, we have a ray depth of 2, and on the right hand side we have a ray depth of 4. So you can just see the difference in that transparency as opposed to refraction. Okay, so a lot of information to get through. Let's move across to Katana and Arnold and actually just quickly look at some of these things just so you know where they are. Hopefully what we've looked at in Keynote is enough for you to understand the concept, and there's not then a huge amount of things that we need to actually show inside of Katana. But let's go there now just so we can familiarize ourselves with where these settings are. But I'm not going to do loads of renders, otherwise you'll get very bored. Okay, so here we are in Katana, and let's just go ahead and grab an Arnold global settings. Okay, so here it is, and we're just going to open it up in the editor, E to edit. Here it appears in the parameters, and you can see what we have here. If we close this up so it's clear, we have AA settings, and this is where AA samples are. We then have lighting, and this is where we have both our diffuse, glossy and refraction along with our ray depth below. Okay, so an AA sample of 1 basically is 1 squared. We know that what that's going to give us is a value of 1. 1 squared is 1. Okay, if we make the value of 1 2, we're going to get a value overall squared, which is 4. Okay, now we then have down here under lighting the diffuse, glossy and refraction samples. So with our diffuse sample set at 2, it's 2 squared times by the AA. So a value of 2 times by the samples is actually going to give us a total GI diffuse number of 16. Okay, the same with the glossy, that's going to give us 16, and the same with refraction, that's going to give us 16. So by the time we add 16, 16, 16 and 4, we're getting a total ray depth of, we're getting a total number of rays of 52. Okay, so even with these numbers super low, we're still getting 52 rays being fired. Let's say we put this up to something that is a more production level. So let's say we have overall samples of say 6. We have diffuse samples of say 6, so that's going to be quite important. Glossy, maybe we think 5 is going to be enough. And the refraction samples, well, for the small amount of refraction we have in the scene, it's quite small, we can get away with samples of 2. Okay, so we've got AAs at 6, we've got our diffuse at 6, we have our glossy samples at 5, and then we have our refraction at 4. What does that give us? Well, the problem is there's no visual representation to tell us, has this made quite a difference? Well, I can tell you we are now producing 2,808 rays in the scene. Okay, so our AAs are giving us 36. Once we add the 16 diffuse on their own are giving us 1,300. The glossies are giving us 900, and the refraction rays are 576. So once you add all that together, you're almost at 3,000 rays. So if you're going to render with these settings, you're definitely going to be needing to go and make a cup of tea while it goes through. Okay, so keep the values low, and hopefully things are going to be okay. Now let me just show you the spreadsheet in order to help you understand this. So let's quickly jump back to the Mac just for a moment while I show you that. Okay, so here we are in Numbers. I'm going to give you this setup in both Excel and the open office system as well. Pretty much the maths are straightforward. You probably thought, man, Matt must be clever if he can add up all those squares one after the other. Actually, as you can see, I was simply typing it into numbers or Excel while I was talking to you. So what we have here, let me just show you the workings out. AA basically is the total is the number I put in squared. Okay, so 6 squared gives us a value, and trying to screw this up, of 36. The diffuse, which we added as 6, you can see what that's doing is it's taking the diffuse value of 6 and squaring it, and then timesing that by the AAs, which are then squared as well. Okay, so that's giving us the 1296. We're doing the same thing for the glossy, so we're basically squaring this number and then timesing it by the AAs, which are then also squared, and the same for refraction. We're then simply taking 36, adding in the 1300, adding in the 900, adding in the 570. Okay, and that gives us the final total rays, excluding any rays that may be on the lights. Now, the reason why we're not including the lights is simply because the lights seem to, from my understanding of Arnold, work slightly differently. Okay, and let's just zip back across to Katana quickly to have a look at the sampling on the lights. Okay, but I haven't added in those values in my calculations just because there's so many unknowns. I mean, if you think about some of the shows that have been around recently, Spider-Man, for instance, that was an Arnold show, you could literally have thousands and thousands of lights, so it becomes quite difficult to try and calculate how much extra rays those lights are going to be making, especially as some lights may have a much lower sample rating than others. Okay, but let's dive back into Katana just to look at how that's working, and we'll also look at the ray depth as well. Okay, so back in Katana, let's just drop back to our node graph, and let's make our light. So we'll make a gaffer. Just pop this here, and in our gaffer we're going to just go ahead and we're going to say we're going to make an Arnold light. Under gaffer we're going to right click, add a light, just like we did last week, and we're going to go to our material and let's add a shader. In fact, let's add a shader here, and let's just go with a straightforward, well, a disc light is the same, is kind of an area light, same as a cylinder light and a quad light. So I'll just make a quad light, and I'm going to open up this and just come over to a full screen, and you can see here are the samples for the actual lights. So as I said, what this is doing is this is going to basically be the samples for the edge of the shadow where it becomes diffused. Okay, so if you're finding that you've got shadows that have got soft edges and it's noisy, it's obviously going to be the AA, because this value is squared and then times by the AA. But if this value is low, even cranking up the AAs isn't going to help you. Okay, so you're always going to need, if you've got these soft edge shadows, to increase the samples here in the specific light itself. Okay, and I believe that every light in Arnold that produces shadows has this sample value here that needs to be adjusted. Okay, so that's where the samples are in the lights themselves. Now, if we quickly return back to the Arnold settings, you'll also note over here, if I just go full screen just to help, this is where under the ray depth you'll find you have the depth itself. Okay, so you've got the total depth, so this works as like a cap, so you can't push anything above this value. So even if I said my diffuse depths is 15, they're basically being capped by this value here. So you want to make sure that these values are never higher than this one, otherwise you're just wasting your time. Obviously you can increase this to 15 and then you're going to get the benefit of higher numbers here. So the diffuse depth is the number of ray depth that goes for the diffuse light. Then you obviously have your glossy depth, your reflection depth, and your refraction depth. Okay, so that is all of the main settings just for dealing with noise within Arnold. Now if I close these down, there are other things here. So things like under cameras, you've got things like what kind of camera type are you using, what kind of shutter type, so you want box or triangle. You can look under things like geometry, and you can do various bits and pieces here. And a lot of this is becoming more specific to Arnold and things that I'm kind of not going to go into. You've got things like gamma correction here, so you can gamma correct your textures. At the moment they're obviously all set for linear, being a value of 1. We'll be talking about color management in Katana 201, so we'll get onto that kind of thing. Various other bits and pieces. You've got miscellaneous settings here, so you've got things like bucket size, you've got how you want your image to kind of come up in the IPR. So often I like spiral, which means that instead of getting the render going across, you get it kind of going round and round. Doesn't really do anything other than makes it look a little bit more interesting. And various other bits and pieces. Okay, so I'm going to leave all that as is. Let us now go back quickly to Keynote and look at render passes, and then we will come back into Katana and actually build some render passes and render out some things based on our Lego scene. Okay, so let's do that now. So Katana render passes, by default Katana starts with a primary render output, sometimes called the default pass. And the render output define node is used to define render outputs inside of Katana. So that's the main node we're going to be using. And with it we can set the type of render output, such as if it's color, a point cloud, etc. The output file type, color space and location, and the actual name itself. Now we can define and override the color output. And again, this is done by the render output define node, and it can be used to create a new render output or override the settings for an existing one, just like many of the nodes we've seen in Katana. The primary pass is the default pass, and setting the pass name to something other than primary results in more than one pass. And Katana provides feedback below the output name parameter that displays whether or not you're creating a new pass or editing an existing one, and you'll just see that when we go back into Katana in a moment. Now various output types are available in the render output define nodes, and for Arnold these are color, raw, script, prescript and merge. You can see from the definitions here what's happening with those. Now the most useful one is usually color, which is for most renders, or merge, which enables you to take all of your render passes and put them into a single OpenEXR file. You also have the ability to run scripts before or after the render command is done, or you can just output a raw image, which obviously is no color management. Now, defining AOV passes allows data from the shader or the renderer to be output during render calculations. And this is obviously just the normal way AOVs work. And as we know, AOV stands for arbitrary output variables. So these are all your point pass, normal pass, Z depth, etc. And the AOVs in Katana for Arnold are created using the Arnold output channel define node. Okay, now when defining AOVs, 3 variables are needed: the channel name, the channel type, and then the filter type. Now unfortunately these aren't defined anywhere in the manual of Katana, so I've spent a bit of time with the help of Deke over in LA to put together a list for the ones for Arnold, and these are going to be similar to RenderMan, but we'll talk about RenderMan obviously later when we get into that in the next course. Now for Arnold, for the AI standard shader, which is obviously the one you're going to be using more often than not, we have beauty, direct diffuse, direct specular, emission, indirect diffuse and specular, reflection, refraction and subsurface scattering. And for all of those they need to be a data type of RGB, and they need to be set to Gaussian filter or whatever you choose, but Gaussian's the standard one. Then we have the AOV channel names, their types and filters, and these are a little bit more complicated. We basically have an ID pass, normals, point, a prefs, Z, CPU time, motion vectors, opacity, ray count and texture time. And you can see I've defined what each of those do. Ones I don't know is texture time. It's very new to Arnold, has only just come in about 2 weeks before I recorded this, and there's no description of what texture time actually does. And also note that a lot of the data types for these are different, and they need to be correct when you specify them inside of Katana. So there's a whole mixture of float, RGB, integer, point, vector, etc. And the only thing to note with the filters is that for the Z depth we're going with closest, and we may also want to change the point pass filter type so that we don't get any anti-aliasing on that, because we don't want anti-aliasing, we just want a clear smooth edge for that point pass. So from here, let's drop back into Katana and actually look at this before we wrap up the lesson. Okay, so here we are just loading up Katana again. We're just going to go into File, and I'm going to open up class 9. You can see I've got a bit of a different layout. I'm beginning to settle on a layout that I think is going to work for things moving forward. And let me just show you what I've done. So first off, I've got this interactive render filters here. This is basically all the render filters we talked about last week, plus a couple of extras. And that basically gives us all of this. I've renamed them a little bit, but that's pretty much all of them. And again, you'll have this in the script. Then I've just got geometry. I've got cameras. This should be cameras. Let me just rename that. So cameras. Then we've got obviously our materials. And then I've got just a 2D section here, and just so you can see this bit of fun. This is a new background I shot for this shot. So I got rid of the table from last time. I've decided to move it slightly. This sheep was just there really for focus, and our model goes right over the top of it, so you don't see it at all. Again, shot with a Canon 5D Mark III on a 50mm lens, same as the last time. Then we have collections, and what I've basically done is nothing with this. I will talk more about collections next week, but it's in there for when we need it. Then we've got pre-pass assignment, and these are just things like the material assign, visibility assign. I've got an attribute script here, which is basically converting my little Lego man. If you remember, we had a Lego man. I'm just converting that with this script, set attribute type to sub mesh. So I'm converting the polygon to a sub mesh with this. And then my Arnold OS, or my Arnold object settings, I'm then just basically taking that subdivision surface and I'm giving it one iteration here. Okay, and I could also adjust smoothing if I wanted to. Okay, then we have my lighting, and we're not going to talk much about this, but there was some talk in the forums about how do we get the Skydome to actually have a material. Well, this is how we do it. I'm going to leave it there for you to have a look at. So this is basically a shading network which applies the material to the Skydome. So we've basically got a image coming in here. It's the 2K lat long of the deck. So it's basically the camera where this table was shot in a fisheye lens all the way around and converted to a lat long. That then goes into my Arnold shading network, and then we apply the material, merge it, and then assign the material here. Okay. Then we have our lights. So that's where our gaffer may be merged if I was using it. Then we have some object settings. So this is basically setting up my anti-aliasing and various other bits and pieces, all the things we've talked about. For this instance, I'm going to set my AAs just to 1, just for speed. Or if I wanted to, in fact, we could just come over to here and grab the sample 1 AA and drop that in. Probably all we need to do. Then we get down to our render passes that we wanted to talk about. So first off, we have this render output default, okay, and this is just called beauty. And all we're basically doing is we're giving it a name. We're saying it's the beauty pass. We're saying the type is color, and there's lots of different types in here. So we want color. There's obviously deep, there's shadow, and we looked at shadow last week, and various other things. The color space is linear. The file extension is OpenEXR, and it's an RGBA channel set. Okay, and then down here I'm basically saying, instead of the local type being, the location type rather being local, I've changed it to file, and then I've given it a name here. Okay, so it's pretty straightforward. When you bring it in, if we make a render output define here, you can see if we just load it, you've got the name here, which would be your render pass. Render pass. You've got the type, which we're going to have color. We're going to have color space linear EXR. There we have obviously the channels, as we just saw. Local you change to file, and then file you decide where you want to put it. Okay, so that will render out just the straightforward beauty. Now, with regards to getting out the other passes, we use, as we talked about in the keynote, the Arnold output channel define. Okay, and again, you'll obviously find that under Arnold output channel define here. And if we just have a quick look at it in its raw state, we've got the name, we've got the driver, so it's usually obviously going to be an EXR file, the channels, the type, so depending on whether you're doing like vectors, like motion vectors, or whether you're doing RGB, or whether you're doing float, or even something different, a string for instance, you can choose that, and it will obviously make a difference, as we saw for the different types of render passes, which one you go with. Then you've got your filter type, and that's pretty much it. So if we go and look at this one for our diffuse, just get rid of that one, you can see the name we've given it is direct diffuse pass. That's just the name we're going to be calling it. The channel, this is direct underscore diffuse, and this is, as we saw in the chart in Keynote, this is the actual Arnold render pass name, and this needs to be exact, otherwise you're not going to get anything out of it. The type is RGB for this one, and everything else is default. And then we just come down to our render output default define rather here, and we just say, again, the output name is going to be direct diffuse, so that's going to be the actual name that we're going to be using. Again, its color space is linear EXRs, and the channels now, if we open up here, you can see these channels are the channel here that we're calling in from above. Okay, so that's the direct diffuse pass is the name that we gave it here above. Okay, so I've basically done that for every single one. I've made an indirect diffuse, I've made a direct specular, an indirect specular, and a reflection. Okay, then we have our AOVs. Okay, so these are kind of similar but slightly different. So it's a Z depth pass, it's an EXR, its channel is Z, which is again the name that Arnold specifically gives it, and this is a float. Remember from the diagram, this one was a float. Then we have our point position pass, and this is a point type. And then finally we have a normals pass, and this one is a vector. Okay, so they are all the passes. Now at this point, if we were to come down to our render settings here, these are the render settings that, if we just go full screen so you can see them, these are the ones that define the camera we're rendering through, the actual renderer, which is Arnold, and then the resolution. Okay, so all that's good. I'm not making any changes there. Then we have our renderer, and if you remember, the renderer basically just renders, and we're going to render everything out of this. Okay, so we're not going to be making any changes. Now here in the output, you can see that these have all been added. Okay, so these are all the outputs that have been put in by default. Okay, so there's nothing that we need to change there, and they're all going to my desktop as required. Now, one final thing, just back at the render settings, I forgot to mention here, this interactive output, these are all the render passes that I want to actually render out. So I actually need to select all of these, otherwise you're only going to get one, or it's going to basically not give you the right render passes. Okay, so they all just need to be checked. Primary, you can't really get rid of it, so often I would just go with my beauty being primary, but for this instance I wanted to name it properly. Okay, so they're all the passes at the bottom, and then we literally come down to the bottom and we right click and we say hot render, which we now know basically renders to disk. Okay, so that is setting up the render passes. Now you may say, what happens if I want to put all the passes into one EXR? Well, that's pretty straightforward. That's what this render output define does right at the very end. If I switch that back on and we have a look at it, this one basically has the type set to merge. So we're basically saying merge, and the merge output are all of these passes. So we want to basically take all of these passes and save them onto my desktop called merged EXR. Okay, so again, once that's done, I can literally come in, right click, and do the render. And what that will do is it's going to actually render them all out separately and then do the merge right at the end as a kind of a post process. So that is setting up our render passes. Okay, now I'm going to render these out and just quickly show you what these look like inside of Nuke, just so you can see what we're getting. So I'm just going to come in, right click, and do hot render, and you can see in our render log here that these are all beginning to go through. Here they go. Okay, so pretty happy. All looks like it's going through fine, and we're just going to leave that to now process. Okay, so let's move back over and have a look at what the files look like when they're finished in Nuke. So here we are in Nuke 7.0 v5. I'm just going to select all the files that I've copied across to my Mac, and I'm just going to drag them into Nuke. In they go, and you can see that we've got some good results. So let's just organize these a little bit better. So there are AOVs, AOV, AOV, and that is our beauty. So these are all the kind of passes. These are the AOV passes, and there's our beauty. So first off, we have our diffuse. So if we go with our diffuse indirect doesn't have anything in it for my particular example. I've then got diffuse specular, or direct specular rather. Then we have indirect specular. Then we have reflection. Okay, so let's just click here. I could have output a refraction, but I didn't have anything glass in my scene, so I didn't bother. So there is my image, a little bit bright, so I need to sort this out, but that's going to be okay for this instance. I, of course, can tone it down if I think it's too dark in a grade node. So all those normal things for next week when we come to composite this, I will make sure it looks a little bit better. The indirect diffuse has nothing in it for this particular instance. There is my specular, or my direct specular, then my indirect specular, and finally my reflection. So theoretically, if we grab all of these and do a plus merge operation, we should then get everything together. And we could obviously just add a grade if we felt that was a little bit too hot and just bring it down a little bit. Okay, so that brings that there, and hopefully once we've done this a little bit more properly, we should be able to bring in our background, and we can just do a merge, and hopefully, though this is the first time I've tried it, they should fit. Let's just check the sizes. So that is 1K, that is not 1K, that's pretty huge. Let me just see if I've got a smaller version. Well, that's a 2K version, so I can scale it from there. So there's my 2K version, and I'm just going to add a reformat, and let's just bring that down to 1K. So hopefully they should be the same size now. So if we do a merge, and let's just see what we've got going on here. We obviously have no alpha, and I think I put an alpha in here, so I'm going to just use my beauty just to copy my alpha in, alpha to alpha. There we go, nice and quick, and then view it, and there's our scene. Okay, so obviously needs integration and various bits and pieces, but there it sits quite happily. Now, looking at our AOV passes, just a quick view. Obviously, the depth is the most important, and it actually lives in the alpha. So you're going to have to do a shuffle, and you're going to just need to take the alpha channel and put it into the RGB, and then you're going to need to do a grade node, and you're going to need to fix your black points. So let's have a look. Where's our blackest point? It's going to be somewhere around here before we drop off the edge. Well, there it is. And then our foreground area is almost certainly at the front here. So again, let's just set our white point there. Okay, and then it's just a question of obviously gammering it until we're happy. But you can see there we have a pretty good Z depth image straight out the bat. Then we have our normal pass that looks like so, and our point position pass that works quite happily if we were to add a position to points node from Nuke 7, and we just want our color, which we can take from here. We need our position, which is here, and our normals, which are here. And if we view all that in 3D, we get something that looks like that. Okay, so all good, everything working as we would expect. Okay, so that is as far as I want to go this week. We've probably gone over time, and I want to finish up there. You may have spotted something sneaky that didn't quite look right in Katana when I accidentally, or not accidentally, but quickly clicked on a shader. You may have thought something looks a little bit different there than it has up until now. That I will explain next week, and that is thanks to Deke at the Foundry, who has been doing quite a lot of hard work to try and get Katana into a little bit more of a Maya-friendly state, so that we don't have all our KDs and KTs and things like that. But that will be shown next week. Okay, so we're going to next week briefly look at compositing, just bringing these together and just getting them integrated. I promise that will be 10-15 minutes max, and then the rest of the class we will cover some bits and pieces that have kind of come up during the course that I've thought these might be a good idea just to look at in class 10, okay, including what Deke has done to my version of Katana, which I will be sharing with you as well. So hope you've enjoyed this week. We've covered a huge amount of slides, and we now have a complete system, information in, shading, lighting, look dev, files in and out, looked at a few weeks ago. Now finally we come to the end and have an entire set of Arnold render passes out and rendered. So pretty happy at this point in the course. Class 10, as I said, is going to be just fiddly little bits and hints and tips of things that will be useful to you. And then we will be into Katana 201. So until next week, Class 10, look forward to seeing and hearing from you in the forums. And as always, this has been Matt Leonard for FX PhD.